Alright, so we took a little break in the middle there of fixing up our loop invariant in the sense that we want to replace this English language part with the proper mathematical expression. Right, so this was what we would like to say, right, that J is not a common divisor, and so we plug J in here to this expression. Alright, so let's grab this and go back to what we were doing with our while tree. We're about to make use of the axiom of assignment. So our loop invariant is here. And when we apply the axiom of assignment, right, we're replacing I with I minus 1. And so that's a pretty straightforward process here because we use I in just one place. So we'll split this across a few lines. And so that's an application of our axiom of assignment. So how does this new post condition, right, this part here, how does this relate to our loop invariant and the condition, right? That's what we need to glue these things together. So we're going to have to make use of our rule of consequence again. Right, and so what we need to verify here in this application is that the loop invariant and the condition implies this this precondition that we generate using the axiom of assignment. Right, so that's something we need to be sure of, right? And so I would encourage you to expand upon this, writing down the loop invariant and the condition, and check that this holds, right? So that's what we need to do. So we end up having that applied along with our axiom of assignment from above. So we'll make a little abbreviation here. And we now would have completed our proof tree for the while loop, right? At the top, the leaf node here is an axiom of assignment. The other part is this implication. And so we might ask, well, is this really a valid thing to say? So if we copy this down below here and grab our loop invariant again, we're asking, is the loop invariant and our condition, right? And if we go back up here and grab what our condition is, right, so we're keeping these abbreviations to keep our trees somewhat small in shape, but you need to expand these out when we start reasoning about things. And so this is the question we have. And so does this hold? So what does this mean? Right, so this precondition here, this initial statement, says that everything greater than I is not a common divisor, right? And this says I is not a common divisor. So it must be that every j greater than I minus 1 is not a common divisor. Right, so it's not too hard to reason through this if you slow down and think a bit. It's a little tricky with plenty of symbols and stuff floating around. But that's all that's happening in this application, right? So here we see something that's very important, that the reason that the loop invariant holds when we take this step through the while loop is because the condition E is also true, right? So the condition E is what tells us that I is not a common divisor, and we can thus make this step. So we now have finished off the while loop tree, and we could proceed to work on the trees for the beginning of the program, and we'll do that in the next video.